Well, good morning and welcome to the Inland Marine Expo. My name is John Schulberg. I'm the editor of the Waterways Journal, which presents IMX this year. We have a great education session lined up for you here, titled Innovations in Propulsion, LNG and Diesel Electric. Our moderator, first of all, our sponsor is the Shearer Group Incorporated. Thanks very much to them. Our moderator is Josh Sebastian, Engineering Manager for the Shearer Group. And at this point, I will hand it over to Josh. Thanks.
So we have a panel here to get together, mostly of industry experts on their given systems. What we want to discuss is innovations in propulsion, things that have changed over the last year or two, specifically regarding use of natural gas as a fuel, diesel electric, and energy storage development. Our panelists that we have is Scott Myers from Optifuel, an LNG company, or a natural gas company, I should say. Peter Brooks from BAE for hybrid and electric. David Lee from ABB with hybrid, electric, and energy storage. And then myself, Joshua Sebastian, at the Shearer Group, firm of naval architects. I'm going to be focused on just a couple of major developments within the industry. First things and the exciting as it can be is regulations and things that have changed over the last couple of years that impact what the industry can use. Energy storage in October of last year, 2019, which seems like a decade ago at this point. Coast Guard adopted AFPM F3353-19, which outlines guidelines for vessels with lithium-ion battery installations. This was very important because up until this time, the only guidance we had was dated from the mid-90s and regarded lead-acid batteries for energy storage on vessels. And obviously, in 25, 30 years, the industry has come a long way since using lead-acid batteries. This provides us a good set of guidelines that, as long as we follow, we should be able to get approvals through Coast Guard with no problems. Whereas in the past, any vessel with significant energy storage was a case-by-case basis for review and approval. We went through this on our TxDOT hybrid ferry design, where we started without any guidelines or without anything from Coast Guard, and we just had guidelines from ABS and from DNV, and we designed to the best that we could with those. And then Coast Guard, came out with this policy after the fact, and which provided better guidelines and more clear path for the future. For natural gas, the big change was in 2017, where Coast Guard adopted an international code of safety for ships using gases or low flashpoint fuels, or more commonly referred to as the IGF code. Again, we were midstream on a project when this happened. We were working on a dual fuel conversion in the Pittsburgh region when the Coast Guard adopted these rules, and some of the changes impacting these rules had an impact on the project was not able to be completed. However, there are the studies out that was done. This was done as part of a merit grant, and some of the lessons learned are published at this point in time if anyone wants to look for them. I had a conversation a year ago with people, and they asked me what's the most exciting thing that's happening in the marine industry from a designer standpoint, from an engineering standpoint, and it has to do with the options that we can use these days. 15 years ago, if an owner came to us and asked, and we're talking about propulsion, the only question we really had was what color engine you wanted. Did you want Cummins? Did you want Mitsubishi? Did you want EMD? Did you want CAT? That was the only real thing. It was mechanical driven. It was props, and that was it. There was no real discussion. Now, today, I pull up like 6 examples here, and that's just the start of the discussion. We have, twin screw. We can go triple screw, tier 3s. We can go diesel electric. We can do mechanical hybrid, and these are all options with energy storage. We can get into hydrogen. We can get into natural gas. There's just this myriad of options that we can now try to tailor the propulsion system to the exact needs of the vessel and improve performance, improve efficiency, and overall improve the product. The one thing I am going to touch on just quickly is our current LNG project for an inland towboat. We are working with SCF Marine, in particular their SCF Marine Highway and SCF Container Express, which are triple screw Z drives powered by Cummins QSK-19s rated at 800 horsepower each. We're going to be adding 12,000 diesel gallon equivalent of LNG to the vessels, and we'll be fumigating the engines to displace approximately 50% of their diesel fuel use. So these vessels, when we're done, they will be running between Port Island and Memphis, and setting up LNG fueling on both sides. It will be fumigating. The challenge on this one was working within the IGF code, and the IGF code is very strict. And the way it is written currently is not a lot of leeway to allow for fumigation systems without a lot of rework for a vessel. We engaged with Coast Guard in February of this year, and we worked to develop an equivalent level of safety for fumigation systems to be installed for domestic U.S. flagged vessels that meet all the intent and the safety requirements of the IGF code, but allowed us enough leeway so that we could install fumigation on the vessel. We are anticipating to get approval of our equivalent levels of safety from CG Engineering, which is the group that does the special considerations with Coast Guard. We anticipate getting those approvals by the end of October at this point in time. It's been a very good working relationship with CG Engineering to help develop these new set of guidelines, and we feel that once they are out there and they will end up published as guidelines for everyone to follow, that it provide a path for the integration of more natural gas into the inland marine industry. But with all these systems, LNG or gas, CNG, hydrogen, diesel electric, energy storage, hybrid, the biggest thing that we have to understand is we need data. We need to understand how you operate and what your intent is. As quoted by Sherlock Holmes, there's a capital mistake to theorize before one has data. So with that, I am going to turn it over to Scott Myers from Optofuel, who will be discussing LNG and the state of LNG on the industry. Scott?
Thank you, Josh. Welcome to the conference, and I'm talking from down in the low country of Beaufort, South Carolina, and you'll probably understand where my accent's from when you understand that I'm down in South Carolina. I was asked to talk about what's going on in the rail market first, and then talk what's going on there. So about half my slides are going to talk about what's going on using alternative fuels, and particularly natural gas in the rail market, and then we'll go into the marine market of what's going on here. Optofuel is a 5-year-old company. Essentially, we're a solution company. We provide complete solutions to customers in the alternative fuels area, including any certifications, regulations, designing the system, installing it, and even doing the refueling and putting that in. And we work with a variety of people, but we put together an entire solution for people. In the rail market, so our rail program that we started with 5 years ago was the Indiana Harbor Belt Railroad. We converted 4 of the locomotives to run on dual fuel. And completely replace. And there's these pictures you see here of that, and you also can see the refueling station there. You actually, if you want to go to our website and go to the media tab, you can see video of the refueling of the locomotives there. But the rail market is moving away from dual fuel to 100% natural gas, and for several reasons. One is the emissions. In California and other places, 50% substitution does not cut it relative to emissions. And also what they have found out in analysis on dual fuel is the fuel savings doesn't justify the change. You really have to go to 100% natural gas to take advantage of the lower cost fuel there. The other thing that is going on is there's starting to be some interest in hydrogen. We're actually bidding a hydrogen program, but that is probably going to be 10 years out before that happens. So the real focus in this, in the rail market is going to be focused on emissions and reducing fuel economy, to the owners, to fleet owners. The good news is that in the last 3 years, solutions are now available. Cummins has come out with a line of engines that are essentially zero emissions in terms of criteria emissions like NOx and PM, and also greenhouse gas emissions are zero if you run a renewable natural gas there. And those engines, which are available all up to 400 horsepower, and next year 500 horsepower, are nice because they have no SCR and they have a very passive aftertreatment system, a three-way catalyst. So it's very easy to install them. We negotiated a relationship. We've always had a relationship with Cummins, and in the last year, we've gotten the right to certify these engines, which were for off-road, for off-road. And we already have the certification for these engines for rail, and over the next 3 months, we'll be certifying these engines through EPA for the marine market there. So this opens up solutions that can provide zero emissions, no SCR required, and also have the advantage of having the fuel savings associated with natural gas. So where are we headed as a company? We're headed toward providing a solutions to the rail industry. In the U.S., the Class 1 railroads buy about 5 billion gallons of diesel fuel a year. They're the largest second buyer after the U.S. Navy. So there's a lot of opportunities to replace all of the 37,000 locomotives that are in the United States. Couple of things I want to talk about. Really, it's a matter of going through the certifications and approval by FRA on the locomotives. But this is not a technology requirement anymore. It's really a financial and a political, in the sense of operationally having the railroads learn how to operate with natural gas. But fortunately, there's a lot of experience now with Indian Harbor Bound installing a natural gas station and refueling locomotives, and they have saying that it's really very similar to the way they refuel with diesel, so there's very little changes there. The one thing that everyone needs to understand with all of these fuels is you really should not worry, in my opinion, with where the refueling is coming from, whether that includes the rail and the marine market, because there are enough people out there who will provide you a solution. You should be really focused on what is the best configuration of your hardware, of your ship or for your boat, and whether you want to run 100% alternative fuels or a mixture, and what your duty cycles are so that you know what's going on there. But it's really not an issue of how to do refueling. The technology exists there, and there are plenty of people that if you have a large enough fleet, they will put in your installation and your refueling and provide you the refueling and there. So that's the real key from that standpoint. So what does it look like inside a locomotive, which is actually very similar to a marine? This is our design of our 4,000 horsepower locomotive, and actually we just was awarded a $5 million contract to build this and test it and go through the certifications at FRA on this in the next 2 years. And this uses actually 10 of these 12-liter 400 horsepower systems along with a battery system. On most of the rail market, you don't need a large amount of batteries But in the marine market, depending on your duty cycles, you may need more batteries or less. But the overall system is in terms of having a fuel storage, having the engines that are zero emissions, and the battery system really all tie into the hybrid approach there from that. The good news is it's affordable. A zero emission locomotive, line haul locomotive, is about the same cost as the diesel locomotives. You're really swapping off smaller engines for one big engine. The other advantage is the fuel savings. You can reduce about 20 to 40% of the fuel savings because you can optimize smaller engines to run at the sweet spot, so your fuel cost can be reduced from that. So that's one of the advantages of using multi-engines in both rail and marine, is because of the fuel savings and the lower cost fuel on both. So moving over to the marine market, you've got a very large market where you've got aged equipment used totally in the inland waterways, about 2.5 billion gallons a year. So essentially half the size in terms of fuel economy than the rail market, and a potential lot of savings to the operators as they convert over to a lower emissions, lower fuel cost there. So that's where we're now starting to focus our business as a company, because we believe we've got the solutions in the under 4,000 horsepower market using these Cummins engines and having EPA certification for the rail market. For the marine market. So what's forcing that? Well, I'm actually is part of it is in California. California is going to requiring the repowering of all of the commercial harbor craft. That includes tugboats, crew boats, barges, everything over the next 10 years, starting in 2023. So they're going to require either Tier 4 plus a diesel particulate filter. So you've got going to have an SCR and a particulate filter built in, plus another particulate filter in there to reduce down. Or you're going to repower with an alternative fuel system to take advantage of that. CARB estimates that they're going to be about 4,500 engines that need to be replaced over the next 15 years, and that's going to create a market for either repowering or new boats, and they estimate that there'll be about a 50-50 changeover for that. Okay, so this is a major change. And this is probably likely over the next 5 years is probably going to move to all the 50 states from that standpoint. One thing that's going to make it affordable is going to be the extension of the low carbon standard program and the alternative fuel programs that are going to be extended to rail and marine. And what that does essentially is will allow the fleet loaners, both the rail and the marine market, to actually get paid to use a zero emissions and a non-carbon and a decarbonizing their fuel, and that savings can be used to replace the equipment over the next 15 years. There'll be additional credits too, but those two things alone, and if you look at the analysis here for the 39,000 locomotives in the United States, the reality is that those two credits alone will cover the cost to replace all of the equipments out there, all of the 39,000 locomotives, which is the cost estimated to replace that is about $115 billion, can be replaced with this fuel savings. So that's a key changeover for what's going on. So going down to my last slide, next to the last slide, I mean. So what are you looking at now? Now you're looking at having zero emission locomotives that can be put together in different configurations, either as a hybrid or all alternative fuels like natural gas, LNG or CNG, or going with hybrid if you still want to have a diesel, hybrid, natural gas solution. A good example of this is just on these two pictures that I borrowed from Josh, just showing the example. Next year, there'll be a 15-liter, 500 horsepower, zero emission locomotive certified for marine. You can put 3 of those together and have your 1,500 horsepower towboat or 5 of them together for a 2,500 boat. And those engines will be under $100,000 a piece, and then the rest of the system the same. So these are going to be alternatives that are going to be available for you as a fleet owner. In terms of if you want to go 100% alternative fuel. In addition, there are going to be new products coming available between ourselves and BAE Systems in order to provide hybrid systems where if you want to configure both a diesel for where you need high power and a combination of zero emission natural gas, depending on your duty cycles, like harbor tugs or something where you're running 90% of the time, you're running at under 40% of the power. You can configure those the way you want to. So you can put as much, whatever variation and what percentage of natural gas versus diesel on those configurations. As Josh said, the real key is understanding your duty cycle and how you're going to use that craft for that. And that's my comment. So I want to thank you for everybody, and I'll turn it back over to Josh.
Okay, thanks, Josh. Thanks, Scott. Appreciate that. So like Scott, I'm based in South Carolina, but living in Charleston. Unlike Scott, I haven't mastered the accent, so bear with me. So I'm going to talk through hybrid propulsion. I've got a couple of examples to work through. Just a bit of background on BAE Systems then. We're the #1 market leader in the heavy-duty electric hybrid sector across North America and Europe. We have almost 25 years experience and just over 12,000 systems in operation in North America and Europe, about 14,000 worldwide. The product's supported by about 155 engineers, backed by about 300 patents. And we have invested roughly $550 million so far in the product and to have 5 generations of product in the field. So a well-established company, heavily invested, focused on primarily North America and Europe. For the marine part of the business, we entered the market back in 2015 with the Norwalk Aquarium research vessel. So it was our first electric hybrid vessel in the US. Since then, we've progressed through vessels in most applications, so a broad range of vessel types shown on the screen there. Right the way through to North America's first hydrogen-powered passenger ferry, the Waterways, which is going into service later this year in San Francisco. The Harbor Harvest vessel, the Captain Ben Moore, and the Hydra vessel were both nominated for Workboat Vessels of the Year, and Hydra actually won in 2018, so very recognizable. And we basically have 3 core systems with 3 standardized systems that we've brought to marine. The first one we call our Hybridgen Power and Propulsion. It's a serial hybrid system that applies to most vessel types, but sort of low propulsion power levels, 300 kilowatts typically and below. Then we have a parallel system called Hybridgen Assist. That's where we take the serial hybrid system and combine it with a much larger main engine, could be diesel, could be gas, to give us a parallel output. So you have the benefits of a serial hybrid system, benefits of a standard propulsion arrangement, and then the benefits of both working together in a boost mode, which I'll talk through, and actually have a bit of an example to work through on this one. And then at the very bottom there, the Hybridgen Power. So it's an auxiliary power system driven off a main propulsion engine. So you're taking your auxiliary power off the same engine that's driving propulsion, eliminates the need to run a separate gensets, and eliminates a lot of service and downtime. And I've got an example for that as well. So 3 standardized systems. So just to give you a little bit of background on our hybrid solution. So the serial hybrid arrangement I'm showing here, it's a variable speed generator, so a variable speed engine and a variable speed ISG, or integrated starter generator, and provides auxiliary power for the entire system. So we work through a propulsion control system to work as a VFD for the traction motor, propulsion motor, which then also provides power through the auxiliary power system to the vessel, and then recharge the energy storage. So you have a variable speed generator providing power to the entire system. Equally, when the generator is off and we're running on energy storage, that energy storage is now providing the vessel auxiliary power and propulsion power through the PCS. The entire system is managed by our system control units. It's completely automatic. It's an on-demand, very responsive system. So for the captain at the helm, the controls are the same, and we'll provide additional displays as more information available to them on the entire system operation. But the message here is that it's completely automatic, it's on demand, and you're pulling the power from the right source, whether it's the variable speed generator or the energy storage, and we manage that for you. So serial hybrid arrangement. When we look then at our Hybridgen assist or parallel hybrid arrangement, it's basically the serial hybrid arrangement, but instead of the traction motor being directly connected to the propulsion shaft, it's now working through typically a combining gearbox. So the propulsion motor connects the PTI on a gearbox. So you can drive the shaft by the propulsion motor, or you can drive the shaft as you would normally by the main propulsion engine, or you can drive the shaft by a combination of both. So both the main engine and the electric motor working together to give you a boost in power. So those are the three common modes. There is a fourth mode that when you're running on the main propulsion engine only, we can actually drive the motor as a generator. So you can have your genset switched off, your vessel auxiliary loads are supported by the main propulsion engine, and if we need any power going to the energy storage to recharge that, we can do that as well. So you end up with a system that is very, very flexible and minimizes the hours in the engine. So you're only running the engines when you need to, and you're pulling the power from the best source available to you at the time. So again, fully automatic, very simple for the captain. Okay, so the first test case then, so this is just an example of what a 2,000 horsepower pusher boat might look like working in a harbor type operation. So I have a table here of a typical, or what we might expect for horsepower levels. Because this is live, I can highlight the first mistake. So about 45% of the time, the vessel operates below 300 horsepower. So that top box should be actually wrapped around the 284 horsepower point as well. But about 45% of the time, you're on a very low propulsion power mode. And that tells you that you can maybe power this off an electric motor rather than driving it off the main propulsion engine. And then when you go down the table, you're certainly going to be in a main propulsion mode. But at the very bottom end, you can see there's a very small amount of time where you're up above 1,600 horsepower. So instead of investing in two 1,000 horsepower engines, you could invest in two 800 horsepower tier 3 engines and use the electric motor to boost up that extra bit of time to those higher power levels. So straight away you can see low power propulsion is a good fit for hybrid. Boost then can be combined with a main engine plus electric motor. So there's two modes of operation there. I've tried to get this in a bit more of a visual slide. Try to get this onto a chart, so just make it a little bit easier to see. But the bottom left corner, you can see 45% of the time you're below 300 horsepower. So you just run on electric hybrid operation. So that 45% of the time, the main propulsion engines are off. So you're saving on maintenance, you're extending engine life, you're gathering all of those benefits. If you have energy storage, and depending on how much energy storage you have, the generators may be off as well. So you can have zero emissions mode. And again, you're reducing hours on the generators and pushing out service intervals as well. When you switch over then into a higher power level, so go above, in this case, 300 horsepower, and you're into the main mechanical mode, then your main engines are on. The motors can be driven as generators, so now the main propulsion engines are providing both propulsion power and vessel auxiliary loads. If there's energy storage, we'll be recharging energy storage as well. And then as you approach the higher power levels, your main engines are running at the 800 horsepower level, but now your propulsion motors have come in to pick up the extra 200 horsepower on each engine. So you've got two 1,000 horsepower systems available to you. But the beauty is you've invested in two engines, but they're tier 3 800 horsepower. You've invested in two generators, but they're now variable speed. With energy storage helps the system efficiency, but the whole system is, for the captain, fully automatic, and it's completely on demand. So you've got the benefits of everything working together as one. So just summarize some of the benefits then. So it allows the owner to right size the main engines, target the engine size for 95% of your need, and use the system flexibility to boost up for the higher power demand. Certainly reduce the demand of the main engines, in this case by 45%. But anytime you're running on that hybrid system, your main engines are off. So that's extended life, extended service. Reduce your genset hours if you have some energy storage in the system. So again, that system is fully automatic. If the power levels are low, the engines will come off and they'll just run on energy storage and then bring the gensets back on when you need to, fully automatic. Reduced overall fuel consumption, both between the propulsion engine and the gensets. Extended engine service intervals we've talked about. Typically, you could double those in this particular review. Reduced overall engine room noise for crew comfort. So you can now give some thought of where you put the gensets. So when you're running in a hybrid mode, the gensets are away from maybe the crew areas. So anybody who's sleeping on board or near the kitchen area, you can minimize noise level impact on the crew. And certainly lower emissions when you're running in the electric hybrid mode, particularly if you have energy storage invested as well. So very flexible system with a lot of benefits. Then when I look at Hybridgen Power, so as our second example then, this is where we have a variable speed generator driven off the main engine. So the test case here is the Christopher parsonage vessel, 2 by 4,000 horsepower main engines, or EMDs. And we took out our ACBL, took out 175 kilowatt genset and replaced it with our 230 kilowatt variable speed generator. So easily cover the power match. The system arrangement looks a bit like this. So it's a Carl center gearbox on the front of the engine, driving a variable speed generator is what we would propose today. That then variable speed generator goes through our auxiliary power system to an AC filter to give you a clean power supply for the vessel. In this case, energy storage is completely optional, not required at all. You can just have the variable speed generator with the aux PCS and filter. Last year, we had MJ Bradley run an analysis. So the vessel's been in operation for about 3 years. Hopefully I'm still broadcasting. I've got an error message. But MJ Bradley reports, they looked at the vessel going northbound and southbound. They did it without the hybrid system in operation and with the hybrid system in operation. And they found that when the vessel was going northbound, the main engines were working heavier against the current flow to maintain speed. The engines were a better fuel point, so the power generated by the ISG was at a much better efficiency point than an equivalent genset, so you got a better fuel saving there. And then going southbound, when they were flowing with the current, there wasn't as much demand on the main engine, so the BFSC point wasn't quite as good as it was northbound. And then you got a smaller cost saving or fuel efficiency saving compared to main genset. So that's the difference between the two. But overall, in a round trip operation, they were getting about 25% fuel savings overall. Plus, they're not running a genset. So in this particular case, that worked out to approximately 15,000 gallons of fuel saved per year. The system itself is basically maintenance free. It's designed for greater than 52,000 hour life. The only maintenance would be associated with the gearbox, which is on an extended interval. So you compare that to a fixed speed genset where you're servicing every 250 hours, you've just eliminated all of that work effort. And then for the crew, it was improved reliability. Vessel uptime was improved. We didn't end up with genset failures. Main engine runs. Our system is built for life.
Thanks, Josh. And also, I definitely want to thank IMX for this virtual platform. And I just want to say, first of all, this is not my office. This is actually, I get the pleasure in being in my hometown of Jeffersonville, Indiana, and we have this wonderful Howard Steamboat Museum right here. And for those of you that don't know, the museum is truly a celebration of the boats that the Howard family built starting around the mid-1800s. The shipyard is just immediately across the road from this beautiful, this is a gorgeous house. I love that myself. But they are known as the premier boat builder of the time. And around the turn of the 20th century, they became the inland towboat and workboat premier builder in the industry. They were successful for 107 years. After that, the yard changed hands a few times, and then it was known as jet boat, which many of us on the conference know, and I spent many a day in there as a alumni of jet boat, crawling through barges and boats. So I thought, what better place to be in to talk about battery hybrid innovation in the industry than really kind of the birthplace of where it all started. So please stop by if you get a chance. You're in the Jeffersonville, Indiana area, and stop and see this gorgeous house and everything that they do to celebrate towboats and workboats in the industry. So let's get to the meat of what I want to talk about. First of all, why are we talking about these? And the other presenters talked about a few of these things. I could talk about IMO, I could talk about zero emission ports, all those things, but really for us inland guys, what does that mean, right? That, if you see the emblems that I put down at the bottom right of this slide, the Shells, the BPs, the Totals, they have net zero emission goals by 2050. That's pretty aggressive. And what they do is not the cleanest, right? They have all kinds of upgrades in their plants they can do, and so on and so forth, but they're going to put a lot of pressure not only on their internal facilities, but also who they're using as contractors and service providers, thus inland towboat, tug operators. They're going to put a lot of pressure on them to get to those goals. So next, I just kind of want to walk through what at ABB we see the progression getting us there. And we've been around for over 130 years. We have 1,300 vessels around the world that have our systems installed in it. And we see that, we're at the start right now. Diesel, electric, LNG, methanol, all those types of things, those are here today. But we have to quickly progress to something different when it comes to things like energy storage, shore charging. The grid power is much cleaner than the power that you produce on a vessel itself. So once you start introducing that, you get the benefit of that cleaner energy, right? Then from there, we move into fuel cell. And, I kind of hate to mention that sometimes for the inland group because we're, again, still way back in the diesel electric LNG kind of stage. But the proof of that technology is happening today. At ABB, we'll have the world's first inland towboat with a fuel cell system in it next year. So the world is progressing there. And then as you see the further progression into 2050 and zero emission, the way that you get to that zero emission with fuel cells is when you start to get to carbon-free hydrogen. A lot of us hear about the offshore wind industry and what is that, what's happening there. That's where you get the green hydrogen, where you get truly zero emission out of the vessels we operate today. Let's dial back just a little bit and let's talk about our industry, right? Part of this industry for over a decade now. Love it. But we typically are slow to change, right? And a lot of the things that make us change are things like we talked about already, regulations, what the companies that we service are demanding from us, right? So our first progression, like I said before, is the electric world. Right here, I just kind of showed a simple system where you have the generators. Scott has gone through this, and Peter already. But what I really want to make sure people understand is what has circled there in the electric side, right? The electric is the most important because it future-proofs these vessels. Those of us that know these towboats, these inland boats, these things last forever, 30, 40, 50 years. Even Amherst Madison today is still operating paddle wheel boats. So, these things last for a long time. So if we're looking to build a vessel today, we need to keep future-proof in mind. And this is where I tell people it's most important to have the electric motor as your main propulsion, whatever it may be. And Josh was so kind to send his rendering as well. As you can see, it's traditional shaft line convert versus an L drive or a Z drive situation. But what that allows you to do is it doesn't matter what energy source is behind those electric motors. The electric motor just wants to consume that energy. So you see In the example on the left, we have generators. Still use the diesel engine possibly for generation of power. The example on the right has the generators, and just like we heard earlier, it could be LNG, it could be diesel. But then we also have batteries installed in there. And it doesn't matter, again, what power is back there because we have electric motors installed. So with that in mind, I really want to talk through this battery revolution and what we've got into. And I'm going to touch on the Coast Guard at the same time as with our Made in the Mist project as the first-hand example. But also, I'm going to kind of speed through this a little bit because I want to make sure we have time for Q&A. I feel that's the most important part of this session. So we can run through all these examples of how to use energy storage, but Josh and the rest of the guys already stated the most important thing of what we do at ABB at first is figure out how do you use the vessel that you have. Is it a fleet boat? Is it a unit towboat? Is it, a shuttle boat on the lower decks? How are you using that particular boat? And we can look at all these areas and how they fit into your application, right? So spinning reserve, again, I call it over-insurance. Instead of having a generator online or an engine online that you don't need, you have batteries there readily available, right? So if you're a standby, you don't have to have any engines running because you have the battery there that would be able to power up immediately. Peak saving, bumpering and holding, this is when I say if you're building a tow, you just have to hold it for a little bit, have somebody throw a line around or a wire around. You can use the batteries for that boost versus bringing another generator online. Dynamic performance, where I love saying ludicrous mode. Power on demand versus waiting for the engine to spool up. You have immediate power. Think of a Tesla compared to a Ford F-250, right? Tesla will blow it off the line because you have that immediate availability of power, as well as electric motor has 100% torque at 0 speed. So you have all that torque right there available for you. And then strategic loading, this is where I call it harmony. This is where you can really level load all those gen sets, level load the system with the battery to make sure you're optimizing the entire system. And then, of course, zero emissions. We've had several projects and currently working on several around the world for all battery towboats and tugs. In these areas, emissions is key. So we are looking at an entire tug and towboat with batteries that has shore power, where they can come back in and while they're waiting for a vessel or while they're in the fleet, right, waiting for a larger boat to come in to switch barges on, they can go ahead and charge. These are things that are out there compared to where we're at today, but they definitely are there. And with that, I just one of the things Josh and I talked about before this was how is the kind of progression with the Coast Guard going, and how are they adopting some of these new technologies? And again, with the Made in the Mist project that we have, which is the first new build all battery ferry in the United States up in Niagara Falls, I would say there's definitely a learning curve, right? I think we can all say that. Really, first adopters always find bumps in the road, and our partner up there at Made in the Mist is definitely a first adopter. With that, and Josh, we were right in the middle of the new ASTM adoption for Coast Guard. We were going through all the approvals when that came along. So with that, we have a lithium-ion system. They were looking at old CFR with lead acid batteries. So we had to get through all that. There's a lot of bumps along the way, and one of the biggest things the ASTM guideline brought along was the safety aspects and what's required for it. A lot of the battery manufacturers that we utilize know the batteries, know how to build them. They're all class approved, but it's really getting the Coast Guard to understand that system, and that's where the ASTM adoption really helped them out through that process. So again, I want to make sure I respect the time for Q&A because it's most important. So with that, Josh, I want to hand it back over to you.
All right. Thank you very much, David, and to Peter and Scott. We do have a few questions here. I'm going to go over some of them, grouping some together. The first one that we've got, and for those of you who don't know, if you should see a Q&A tab off to the side, if you want to enter any questions in there, we'll try to get to as many as we can here. There's two questions here, and Scott, more up your alley with natural gas. You mentioned the low carbon or alternative fuel credits program. Two questions, if you have any insight. First, would that be extended to partially fumigated engines, similar to the one that we showed with the SCF? And two, do you know approximately the timeline for when that will be extended to the marine industry?
I'll answer that two ways. I'll answer both those questions. My belief, it will not cover fumigated systems because it's really driven to zero emissions or very low emissions from that. So my gut level is no. And my answer on the second question is I believe in California and other places that will happen in the next 2 years, and some of that is also requiring lobbying from both the industries. But it's a huge financial changeover. Source to replace your old equipment. If the industry for both the marine and the rail market to lobby that. Okay.
All right. Thank you, Scott. Next question, David, to you first, and Peter, you probably have some input. What do you feel is holding back the adoption of new technology, specifically energy storage, diesel electric, and fuel cells from taking off on the domestic U.S. market?
Well, I guess there's a bunch of ways I know that one, Josh. And it's a really good question. One is that there is some systems out there that have been installed that are dipping their toe in, right? We in the U.S. are very reluctant to change, and when it comes to that, we're a very mechanically minded industry at the same time. We like our gearboxes, we like our engines, and so taking that leap into electric is usually the first large one that a company has to make. But with that, when we start talking batteries, it's not only just the inland industry, it's just the adoption of batteries in general. That is really picking up steam throughout other industries inside the U.S. And with that, that's what the inland guys want to see, right? That's what it says. When I was at ATBL, we definitely were on the forefront of what we wanted to do. But batteries was always kind of too large of a jump, right? But as we see some of these other industries adopting those, same thing on fuel cells. Actually, to be honest with you, that's one of the biggest things on fuel cells right now is no different than what we see in the LNG is. Where are you going to get hydrogen from? LNG, where are you going to find it? The infrastructure and the supply chain has to be there first. So that has to be overcome for fuel cells, but for batteries themselves, it's just getting used to the technology, and the price is continuing to drop today as well. So those both together, we're not that far away.
All right. Thank you, David. I'm going to ask a little follow-up on that. Do you feel that as it gets adopted more on the ferry market, that it will eventually start spilling over more into the inland towboats and harbor boats, things like that?
Yeah, I definitely do. I mean, one of the big things that I always tell people is a ferry market is point A to point B. It's kind of very similar to what an OSB or PSB would be doing, leaving from Port Fourchon out to a rig, right? Not very dynamic, but it's proving that batteries and fuel cells and so forth can work in vessels. People that don't know towboats and tugs, they don't know how dynamic these vessels are, and it's very important to understand that. And with that, these systems were lagging behind what is happening in the ferry market, but the ferry market definitely is driving the adoption of that because it is point A to point B, and it's a lot different, low profiles and everything that we'll see, but it will definitely help what's going on the inland side.
Peter, you mentioned hydrogen as for the San Francisco ferry. I know that's been around, been talked about a bit, and it is gaining some interest, especially as zero emission stuff's coming down. Do you have any insight on that being propagated into the inland marine industry as a whole, outside of some of these sensitive areas like San Francisco?
Okay. On a locomotive, you're already electric powered. unlike so your traction motors on a locomotive are electrically powered, whether either DC or AC. So to change over from a diesel engine to a generator, it's very straightforward. You replace it with a natural gas engine or a hydrogen fuel cell along with a battery storage on that. Really, as I said, we're providing natural gas solutions now, and we're bidding a hybrid program in California there. But it's really the only thing really going to drive the hydrogen market at this point is the cost still of fuel cells and storage, because the quantity then is still expensive because of that. But I agree that what David is saying is that for those solutions that hydrogen makes sense, and down the road where there's a more affordable hydrogen available, and you're going to see that changing also in the rail market. And like I said, everything is going to be moving toward electric. The tractive part of that, or the motive part of that, or the part of that, and then you just will provide different power sources depending on what the ship or their locomotive needs.
Guys, I think we're happy you're there. A question for him, but when we get back, David, this might be more. You might have some information on this question. Anyone reach and aspire approval on a twin screw towboat using 800 horsepower mechanical hybrid design that are out there currently? But David, do you know if anything?
No. So if you talk about the mechanical hybrid, diesel electric itself, right? There's several examples around the world where they have been, ABS approved, DNV approved, and definitely when we start talking about the offshore oil and gas as OSVs and PSVs electric, working for all the oil majors, but there has not been one in the inland towboat industry. No. Peter, you back? Anything you want to add?
Yeah, can you guys hear me now? Yes, okay.
Yeah.
Okay. Joys of life broadcast. Yeah, so just to finish off on the hydrogen, I got into really the two obstacles right now are availability and cost of hydrogen, which is getting addressed, but hydrogen storage. So certainly a lot more effort needs to be made, certainly to get densities of hydrogen storage up above 100 kilograms per cubic meter, that type size. So work effort there. On the 800 horsepower comment, so tier 3 versus tier 4 is obviously of a lot of interest. For vessels that need 1,000 horsepower, 1,200 horsepower, we're giving them another option. So they can either go triple 800 horsepower, or they can go dual 1,000 or 1,200 horsepower engines, if it's a good operating profile. So anything that's got long periods of low propulsion power and much shorter periods, so say like a 2-to-1 type ratio, much shorter periods of boost power, would be a fit for the parallel hybrid approach. So we're just giving another offering to the market. And that's really what you touched on earlier, Josh. There's now a multitude of options for owners to go and pick from that's a better fit for their fleet. So if you really want twin prop, we can give you a solution. If you want to go triple, then that's a solution too.
Thanks. Scott, you showed a couple of offerings from Cummins, and for natural gas engines up to the 500 horsepower range. I've got a couple of questions on this. I'm going to kind of summarize it into maybe one. Do you know, or if you do, can you even tell us, is Cummins looking at extending that natural gas range into higher horsepowers beyond 500, into the 800 and 1,000 horsepower range that could potentially be very useful for the inland towboat industry?
I do not know the question in terms of what Cummins is doing beyond that, but I will say that it starts becoming a real problem with as you go higher up on a natural gas engine being built on a diesel engine block gets a little bit unfit, loses efficiency. So and also weight becomes more of an issue there. In other words, the big 100% natural gas engines that are used in power systems that do 4 or 5 megavolts of power. They are very heavy and big. So there is a point where it may not make sense to go that way and to use a combination there. But I have no visibility into what happens above 500 horsepower. I know that there are also other companies around the world that have 100% natural gas solutions, and they have not come to the United States with them, and they're out there too. Okay.
Thanks. I think that's all we have time for. John, I believe you wanted to have a few comments to wrap up, sir. And I do, again, I want to extend our thanks to IMX for making this work through all the trials and tribulations that we're going through. We've been very impressed with the platform from our end, and thank you very much, guys. John?
Yeah, and thank you very much, Josh and Scott and Peter and David. Great panel. Thanks again also to the sponsor for this session, the Shearer Group Incorporated. If you're for further discussion on propulsion matters, I would call your attention to a couple of upcoming events at IMX. One is a webinar that begins right now at 11 a.m. on shared experiences putting hybrid to work. That's sponsored by BAE. And then at 2 p.m. Central Time, we have an education session on diesel, Tier 4 engines, and supply chain update. Again, thanks very much, everyone. For attendees, I would invite you to visit the expo hall and engage with our exhibitors. We've got about a good group of exhibitors here. And you can network with one another in the networking lounge. So again, thanks very much, everyone. And that concludes this session.
Thank you, John. Thank you, Josh. Appreciate it.
Thank you.
All right.